Welcome to the next lesson on composite functions. Now we're going to talk about how to actually evaluate a function or two functions that are composites of each other. Let's say that your favorite store is having a 50% off sale. 1/2 of the total amount that you're going to spend. We could call that f of x. Because even though we don't think of that when we walk in the store, it's actually an equation or a function. So, also, you recently got a $10 off coupon. So we're going to call that function x, whatever your amount is that you're going to spend, minus $10. So you go shopping and you find that that the amount that you've chosen or the items add up to, let's say, $200. So if you took 1/2 of 200, you'd have 100. When you go up to pay for the items, you remember that you have $10 off. So you take 100 and you subtract 10, which gives you 90, not including sales tax. Okay, so if you notice that we actually took a function, and after we got the answer from one function, we put it into the next function. That's what a composite function is. Okay, so remember that just a function by itself is taking an x value, plugging it into the expression, and finding your y value. In this case, whatever the y value was, it actually turned into the x value. Okay, it actually became its new x value, and then we put that into the expression for the new function. Okay, so to write a composite function, it's going to look like this, where we take one function and put it inside of another function. Okay. It can also look like this. G of f of x. And then you might have parentheses in the front there. This symbol right here is not really an O, kind of made it big, but it's a little circle, okay? It's basically saying that we're going to take f and put it into function g. Now, I don't have to always find, like, for instance, 200, okay? I could take f of x and put it into g of x. So I could take the expression and put it into the x of g. The way that would be written is like this. So if I was asked to do g of f of x, then I would take g, which is x minus 10, right? And I would put the expression from f into into g. So that makes sense, doesn't it? Because if I were to still find 200, I could still put 200 into x, get 100, and 200 times 1/2 minus 10 would still give me 90. Okay? So we have several functions and their expressions to work with. We're going to try this with a few problems. This is your assignment. Let's try number 1. for number 1, go ahead and add this to your assignment. We're going to work the inside first. So let's do g of 2. G of 2 is going to be 3 minus 2, which equals 1. Now this is the y for g of 2, otherwise 2 comma 1, right? But with a composite function, now we're going to take y and put it into f. So the y becomes the new x. Okay, so take 1 and put it into f, which 1 squared is just 1, but we have to recognize that that minus is not going to be squared. If it's outside the x, you don't square it. So it's still 2 minus 1, which the answer is now just 1. Okay, let's try it again. All right, here's the next problem of your assignment. Let's find m of n of x. Make that -3. Okay, so I'm going to find n of -3 first. And remember, that's an absolute value, and that means times -3 there. So that's going to make a -6, but the absolute value of -6 is going to be +6. Okay, now that's the y value of the first function. That y value now becomes the x value of the outside function. Remember, we do the inside first and then the outside. So m of 6. So -2, 6 squared. Okay, so that's going to be -2 times 36, which would give me -72. Okay, even though I use this 6 to find my answer, my final answer is this guy, -72. Okay, let's try another one. Okay, notice on this problem that you're going to take k of -1, work the inside, and then you're just going to use the same function again. So we're going to say k of -1, that's our inside, and we're going to find out what that equals. So -1 squared. Notice that when you put the -1 into x, that's when the negative actually is squared. So a negative times a negative is a positive, plus 3 equals 4. And again, this is your y value that's going to go into the next function, the outside k. All right? It now becomes the new x. So now I'm going to put 4 into x squared plus 3, which that's 4 squared is 16. 16 plus 3 equals 19. And 19 is my final answer. So the next problems on your assignment are going to be able to try 4, 5, and 6 on your own. Okay, so like for 4, you're going to do g of 10 first, and then whatever your answer you get for g of 10, you're going to turn around and put it into h. Remember, notice that h is -2x, g is 3 minus x, and then we have f of x as well, 2 minus x squared. So wherever you see the function, go ahead and remember to use these functions up at the top. Okay. Remember that if I say f of 3 for number 5, then f of 3 evaluates first, find that answer, and then turn and take that answer and put it right back into f. Okay? Now, number 6 is kind of a challenge because there's no number. You're simply going to just take the expression h of x, negative 2x and take negative 2x and put it into this x right here for f. So when you put that into that x, you're going to square it. Let's see if you can do it. If you have any questions, please let me know. Otherwise, thanks for watching. Stop the video right here, wait a few seconds, and then you'll see the answers on the next slide. Okay, again, thanks for watching.